students, welcome again to another maths lesson. Today we're moving on to another topic, and the topic is matrices, an introduction. So we'll be giving an introduction to matrices. Look at the definition and a couple of definitions under matrices, and then we start with some basic matrix algebra, and then we'll see what happens, or we'll see how far things go with the lesson. All right, and for those of you who have come across the topic, this will be more of a refresher course, and for those of you who are coming across this topic for the very first time, you're welcome, and I can tell you that this is a topic you're likely to come across later on in maths. So if you're ready, let's begin. So like I said, we will start with some definitions you need to be aware of for you to really understand what matrices are. Of course, remember, matrices, that's a plural for matrix. Okay, when you have one, it's a matrix. When you have more than one, you have matrices. So let's start with a couple of definitions. What do you mean by a matrix? It's simply a rectangular array of variables. When I say variables, I mean maybe x, y, stuff like that, or constants. And when I say constants, I mean numbers. In horizontal, when you have horizontal, we mean rows. So we arrange these numbers in rows and columns, enclosed in brackets. So that's what we mean by a matrix. When you have letters and numbers arranged in a bracket or a pair of brackets with rows of numbers and columns of numbers. That is what we call a matrix. Okay, and that is really quite important in maths when it comes to solving some problems. Okay, next up, what do you mean by an element? An element is simply each value in a matrix. It could either be a variable or it could be a number or a constant. So each of the entries you have in a matrix is what we call an element. Okay? Next up, we have the dimension. The dimension is otherwise referred to as the order. So what do we mean by the dimension of a matrix? What do we mean by the order of a matrix? It's simply the number of rows times the number of columns. So the number of rows of the matrix times the number of columns. That gives you the order, or if you like, the dimension of the matrix. And we'll see a couple of examples of that shortly, because it's important for you to really understand what we mean by the dimension, or if you like, the order of a matrix. So I can give you a matrix now and ask you for the order or the dimension of the matrix. It's simply the number of rows, you always start with the rows, times the number of columns. Okay? So a matrix is named, so there you go. A matrix is named by its dimensions. You name matrix by its dimensions. That is the rows times the matrix. So you can have a 3 by 2 matrix, you can have a 4 by 4 matrix, you can have a 1 by 3 matrix, and so on. So that gives you the dimension of the matrix, and that's how we name matrices. Okay? So let's see a couple of examples, shall we? You've been asked to find the dimensions of each matrix. Now remember, when you find the dimension, you count the number of rows first, times the number of columns. Rows first, and then columns. Don't forget that. Rows first, and then columns. So let's see. We've got a couple of examples here. I've got 3 matrices here for you, and I want you to identify or to give me the order of the matrices. So there's the matrix A, there's the matrix B, and matrix C. So I want you to pause the video and then write down the order of each of the three matrices, okay? And once you're done, you can then continue playing the video, and let's just hope that your answer will be correct, you know, same as mine. Remember, when you are writing down the dimension, or if you like the order of the matrix, rows times columns. Number of rows times the number of columns. Take note of that. So let's see the first one. Count the number of rows. Count the number of columns. For the first one, for the matrix A, that's matrix A, and by the way, we also use letters to denote matrices. Capital letters. Matrix A, matrix B, and matrix C. We use capital letters to denote matrices, and for each of the entries here, if they are not numbers and you want to use letters for each of the entries in the matrix, you use small letters, okay? Also take note of that. Capital letters for the matrices, small letters for the entries. Take note. Alright, so for matrix A, what is the dimension? What is the order of matrix A? Rows times columns. Take note. So let's see. How many rows? You've got 3 rows. How many columns? You've got 2 columns. So this matrix will be what? Can anyone guess? Remember, rows times columns. That's right, it's 3 by 2. 3 rows, 3 by 2, 3 times 2, and that's it. That's how you name matrices. That's how you find the dimension of matrices, or if you like, the order of a matrix. Simple and straightforward. Next up, what of matrix B? Again, what's the order? What's the dimension? Rows times columns. How many rows are there? How many columns? Let's see. There you go. 1, 2, 3, 4. 4 rows. And how many columns? Just 1 column. Just 1 column. So, what is the dimension of this matrix? Can you guess? By now, I expect everyone to know it. It's 4 by 1 matrix. That's right, it's a 4 by 1 matrix. So the dimension is 4 by 1. 4 rows, 1 column. 4 by 1. 4 times 1. And finally, for matrix number C, or for matrix C, how many rows, how many columns? 2 rows. How many columns? 4 columns. 1, 2, 3, 4. And so the dimension of matrix C is how many rows times how many columns? 1, 2. 2 by 1, 2, 3, 4. 2 by 4. And you're done. That is how we find the dimension of any given matrix. Simple and straightforward. And this is actually the basics of matrix algebra. It's important for you to be able to correctly identify the dimension of any matrix you're given. Very important. Before you can go ahead and carry out any matrix algebra, be it addition, subtraction, multiplication, and so on and so forth. You need to be able to correctly identify the order of the matrix, which is what we've done here. And so we'll see some more examples later on, but I want you to really get a better understanding of how we find the dimension of any given matrix. And I want to believe with these 3 examples, you have an idea of how we go about doing that. Okay, moving on. Now we have different types of matrix. What are the different types? First, we have what we call a column matrix. Column matrix. Column matrix. A column matrix is a matrix with only 1 column, but it can have 2 or more rows. one column but can have two or more rows. But a column matrix you only have one column. So it looks pretty much like this, where you have 4, 5, 6, and 9. You have just one column and it can have as many rows as possible. So that is a column matrix. So that is one type of matrix. Let's look at other types. Next up we have a row matrix. A row matrix. It's got just one row, but it can have many columns. Just one row, but many columns. So a row matrix is a matrix with only one row, but two or more columns. And I have an example. So a column matrix could be like this. It can have -5, 6, 9, 3, 2, 0, and so on. It has just one row, but many columns. So this is an example of row matrix. So you can see the difference between a row matrix and a column matrix. Alright, let's see the other types of matrices we have. We have a square matrix as well. A square matrix is a matrix that has the same number of rows and columns. So a square matrix will have equal number of rows and columns. It could have 2 rows and 2 columns, 3 rows and 3 columns, 4 rows and 4 columns, 5 rows and 5 columns, and so on. So a square matrix will have equal number of rows and columns. For example, you can have 2 rows and 2 columns. 5, 9. That's a square matrix. You can also have 3, 2, 8, -1, 6, 2, and then 11, 5, 6. And this, you can see, is a 3 by 3 matrix. Also, another square matrix. So far, so good. So a square matrix has got equal number of rows and columns. Moving on. Now, equal matrices now. 2 matrices that have the same dimension. This is the key word now. And each element of one matrix is equal to the corresponding element of the other matrix. So when 2 matrices are equal, they have the same dimension and you can compare corresponding entries. Okay? We'll explain this shortly, and this is quite important when you are attempting questions with regards to matrix algebra. Okay, it's very important, and we'll see more on that in a few moments. Now, the definition of equal matrices can be used to find values when elements of the matrices are algebraic expressions. So when you have a matrix algebra, equal matrices, they come in quite handy. So here's an example. You have to find the values for x and y. So we have these 2 matrices and they're equal. Remember, for 2 matrices to be equal, they need to have the same dimension. It's got 2 rows and 1 column. The matrix to the left and the matrix to the right. It's got 2 rows and 1 column. And if they're equal, what it means is that that entry, or that element, if you like, is equal to that element. That element is equal to that element. And from there, you should be able to carry out some algebraic manipulations to find the values of x and y. So let's see. Now, since the matrices are equal, the corresponding elements are also equal. So you form 2 linear equations. And of course, when you form 2 linear equations, you know how we solve linear equations? Simultaneous equations. You can decide to use the elimination method or substitution method, whatever method you feel comfortable with. Alright? So let's see So you have 2x is equal to y, and then 2x plus 3y is equal to 12. So you have a set of simultaneous equations which you can solve any way you're comfortable with, either using substitution method or elimination method. Alright, so let's see. So you solve the equations using substitution method. So I decided to use substitution method, but by all means you can try other methods as well. You can use elimination method. You don't have to use this. As long as you get your answer right, it doesn't matter what method you decide to use, whatever method you feel comfortable with. If you haven't been told categorically in the question to use a particular method, the choice is yours. You can use whatever method you feel absolutely comfortable with. Okay, so here I've decided to use substitution method. Now what do I mean? If 2x is equal to y, it means here, when you've got the 2x, it will replace with y. It's 2x will be replaced with y. And so you have y plus 3y is equal to 12. And if y plus 3y is equal to 12, y plus 3y gives you 4y, exactly. So you have 4y is equal to 12, and if 4y is equal to 12, to get y, you simply divide both sides by 4. Divide that by 4, and then that by 4 as well. And then when you do that, the 4 goes, and you're left with y, and 4 in 12, you have 3. And that's your value of y. And then given this value of y, you can then substitute in there to get the corresponding value of x. If y is 3, if you've got 3 there, well, let me just show you on the slide. If y is 3, now that we have the value of y is 3. To get the corresponding value of x, you simply divide both sides by 2. When you divide both sides by 2, x is now 3 over 2. Or if you prefer, x is 1.5. Okay, that's it. That's your value of x. And that's your value of y. And you're done. And remember, it's important for you to check these values as well by substituting or like by putting these values into the given equations to be absolutely sure that you indeed correct. When x is 3 over 2, 2 times 3 over 2, 2 times 3 over 2, 2 into 1, and then you have 3 here, and then y is 3. So that is indeed correct. And then right there, x is 3 over 2, 2 times 3 over 2, 2 times 3 over 2, so you have 3 here, plus y is 3, 3 times 3 gives you 9. 9 plus 3 is 12. So indeed, the values of x and y are 1.5 and 3. So far so good. So that's how we carry out matrix algebra. Okay? Moving on quickly. Moving on. Now here's question number 2. Again we have two matrices having the same dimension. And remember, when you have matrices having the same dimension, they're said to be equal. Okay? So if these two matrices are equal, then you can equate the two entries on both sides and then go ahead and carry out your necessary algebraic manipulations to get the values of x and y. Okay? So I'm going to go over the steps. You write this as linear equations. What do I mean by write as linear equations? You equate entries on both sides that are corresponding. Okay, this entry corresponds to that entry, so it's equal. That corresponds to that entry, so that's equal as well. And from there you have your set of linear simultaneous equations we can then solve using algebraic methods, substitution method or elimination method. Okay, so there you go. 3x plus y is equal to x plus 3. And x minus 2y is equal to y minus 2. So from there, you come up with your simultaneous equations and then you solve appropriately. So then you collect like terms, because you can see here you've got x there, you collect the x's together, and then y there, you collect the y's together as well. And so when you do that, when you collect like terms, you will have 2x plus y is equal to 3, and then x minus 3y is equal to minus 2. and you solve using elimination. Well, the choice is yours. You can decide to use elimination method, but I've just preferred to use elimination method. It doesn't matter. If you haven't been told categorically to use a particular method, you can use any method of your choice. Okay, so I've decided to use elimination method, and in which case I've multiplied the second equation by -2. And when you do that, that's what you have. This is your first equation, but that's the second equation now. And from there you can see the question is the same, but the signs are different. And when the signs are different signs, remember, different signs, you add. So with different signs, we're going to add now. And so when we add, what do we get? That bit goes. This goes. And then you have y plus 6y, that's 7y. 3 plus 4, that's 7. And if 7y is equal to 7, what do you just get y? You simply divide both sides by 7. When you divide both sides by 7, you have 1. So y is 1. And so given this value of y, you put in either the first equation or the second one to get the corresponding value of x. And when you do that very quickly, you will get, so if 2x plus y is equal to 3, so if you put it in there, now that y is 1, so you have 2x plus 1 is equal to 3, and so you move that over there, it becomes minus, so you have 2x is equal to 3 minus 1, which is 2, and then again, to get x, you divide both sides by 2, and when you divide both sides by 2, you find that x is 1. Alright? And again, do not forget to check your answer. You check your answer by putting these values into the matrices. The matrix to the left and the matrix to the right to see that they are indeed equal. Now you can check that, okay, and be absolutely sure that they are indeed equal. So far, so good. Are we making progress? Alright, let's proceed. So when you check, you will end up getting that x minus 2y, that is the bit here, is equal to y minus 2. And so you just put the values accordingly. Now since x and y have the same value of 1, just put in the values there, and you see that the minus 1 here is equal to minus 1 there as well, which is the same. Which indeed tells us that these values of x and y are correct. Moving on. Number 3. Let's just number 3. You have a row matrix now, a row matrix there, a row matrix there as well, with 1, 2, 3 columns, 1, 2, 3 columns. So the two matrices are indeed equal, and when you have two matrices equal, you simply equate the entries, the corresponding entries. This corresponds to that, this corresponds to that, this corresponds to that, and you should be able to find the values of x, y, and z when you do that. So when you find the values of x, y, and z, so you select each element equal, and then you solve. So you have 2x is equal to 5, and so from there, to get x, you divide both sides by 2. Oh, 2 in 5, that's 2.5. So the value of x is 5/2, or if you prefer, 2.5. Okay, next up, 3 is equal to 3y, and from there again to get y, divide both sides by 3. When you divide both sides by 3, y will be 1. And finally, 3z is equal to 9. And with 3z equal to 9, to get z, you divide both sides by 3. And when you divide both sides by 3, 3 in 3 is 1, 3 in 9 is 3, and your z is 3. So these are the values of x, y, and z. And you're done. And this is essentially what we do with regards to matrix algebra. Okay? That's what we do. Moving on. Now let's continue, but I want to go back a little bit to dimensions, because I said it's really important for you to understand how we work out the dimension, or if you like, the order of a matrix. So you need to be able to state the order of a matrix. In other words, you need to be able to find the dimensions of any given matrix. Now the order of a matrix is usually n times n. Remember, the n signifies the number of rows, and n the number of columns. Take note. So n is the number of rows and n is the number of columns. Okay, take note of that. Okay, so have an example, or if you like, an exercise for you to try out. And like I always advise, you can pause the video and then try the questions, and once you're done, you can continue playing the video with the hope that your answers will be same as mine. Alright? You've been asked to write down the dimensions of the following matrices. You've been given 4 matrices here: A, B, C, D. So you've been asked to write down the dimensions in each case. By now, I want to believe that you all should be able to work out the dimensions of any given matrix. Okay? Alright, so A, what's the dimension? B, what's the dimension? C, the matrix, what's the dimension? And then D, what's the dimension of the matrix? By now, you should be able to work it out. Remember, rows times the columns. So let's start with A. How many rows have you got in A? How many columns? Okay? Right, look at A. 2 rows and 2 columns. So the dimension of the matrix in A is, yes, 2 by 2. Exactly. So far, so good. No problem at all. Let's go to B. How many rows in B? Just 1 row. How many columns? 3 columns. So the dimension of the matrix is 1 by 3. Exactly, 1 by 3. Okay, so far so good. It's really quite straightforward. It's that simple. Next up, C. How many rows? How many columns? 2 rows. How many columns? Just 1 column. So the dimension is 2 by 1. Exactly. It's 2 by 1. Next up, D. Again, identify the number of rows. 3 rows this time around. And how many columns? 2 columns. And so the dimension of the matrix in D will be 3 by 2. Exactly. It's a 3 by 2 matrix. So that's how we work out the dimension of any given matrix. It's that simple. The number of rows times the number of columns. And like I said, you really need to understand this when we go into matrix algebra proper. Because if you get the dimensions wrong, that may affect your calculations when we start the algebra. Okay? Moving on to the next slide. So now we'll be looking at how we carry out matrix algebra, starting with the addition and subtraction of matrices. Okay? Excuse me. Right, so we will proceed now by looking at how we carry out matrix algebra. And we'll start with the addition and subtraction of matrices. What do we do when we have matrices and we need to add them? What do we do when we have matrices and we need to subtract them? There are steps involved which you need to be aware of. Okay, so you need to know how to solve problems involving the addition and subtraction of matrices. Now you can add and subtract matrices only, and this is a necessary condition, only when they have the same dimension. So where the dimensions are not the same, you cannot add. Forget it. Don't even try. You cannot add. You cannot subtract where the dimensions are not. So if you're given 2 matrices and you want to add or you want to subtract, first of all look at the dimensions. If the dimensions are not the same, forget about adding, forget about subtracting. Just conclude that you cannot add because the dimensions are not the same. So this is a necessary condition before you can even proceed to add or subtract the matrices. They must have the same dimensions. Take note. Okay, so here's an example. You have the matrix A and the matrix B. Now let's see if these two matrices fulfill our initial condition. Remember, our initial condition is that they must have the same dimension before you can even think of adding or subtracting. Matrix A has got 2 rows, 3 columns. Matrix B, 2 rows, 3 columns. So we are absolutely fine. We can go ahead and add or subtract because they have the same dimensions. Okay? So let's see. Aha! So let's see how we add the two matrices. Because already now they've fulfilled the very basic condition of having the same dimensions. So now let's see how we add. Again, it's important for you to know the steps involved in adding. Now, that's matrix A, 5 minus 6, 7 minus 2, 4 and 3, and then plus matrix B, 8 minus 3, 2 minus 8, and then 0 minus 1. So to add these two matrices, you add corresponding entries. Watch as we add the two matrices now. So you take the first two entries in the first row and the first column, you add them, 5 plus 8. We add 5 and 8, you get 13. So that goes in there. So next up, you add the next correspondingly. Don't add the wrong entries. 7 and minus 2. 7 plus minus, well, of course, plus times minus gives you minus. So 7 minus 2 is 5, that's right. So that goes to the second entry. Now for the third entry, still in the first row, 4 plus 0. 4 plus nothing gives you 4. Okay? And that completes the first row. Let's move to the next row. The next row, minus 6 plus minus, now plus times minus gives you minus. So you have minus 6 minus 3. Minus 6 minus 3 gives you minus 9. And then next entry on both matrices, minus 2 plus 8, that gives you 6. And 3 plus times minus 1, plus times minus gives you minus. So 3 minus 1 gives you 2. And that's it. And you're done. So the addition of matrices A and B is that. So I would put here A plus B is this. And you're done with the addition of two matrices. Now let's see what you will get when you subtract. Okay, so this time A minus B, again you have matrix A minus matrix B. You follow the same steps, alright? But you are going to be mindful of the fact that now you are subtracting. You are subtracting. Take note, when you subtract, again you take corresponding entries. 5 minus 8, that's minus 3, 7, now minus times minus gives you plus, so it's going to be 7 plus 2 which gives you 9, and then 4 minus 0, that's simply 4, and then minus 6, minus times minus gives you plus, so you have minus 6 plus 3, minus 6 plus 3 is minus 3, that's right. And then minus 2, minus 8, moving on to the second entry, the last but one entry, minus 2, minus 8. Minus 2, minus 8 gives you minus 10. And finally, 3, you have 3 minus 1. Minus times minus gives you plus, so you have 3 plus 1, that gives you 4. And we are done. So this is the matrix for A minus B. And so that's how we add and subtract matrices. Okay? Now, just very quickly, matrix addition is commutative. What do I mean by commutative? When you have the matrix A and you add it to matrix B, your answer is the same as matrix B plus A. Okay? So matrix addition is commutative. Matrix addition is also associative. What do I mean by associative? If you have three matrices, A plus B plus C, if you add the matrix B and C, and then you add it to A, your answer will be exactly the same as when you add matrices, A and B, and then the answer you add it to matrix C. Okay? Now here's a challenge question before we wrap up today's lesson. You can ask the capital values of x and y in the matrix equation below. This plus this gives you that. Alright? Now take the corresponding entries like we normally do. The two corresponding entries, that's what you have. So you have 2x plus 3y is equal to 5. X minus y is equal to 5. Now, of course, you notice 3 plus 2 is 5. 4 plus 7 is 11. So that is good. So from here, again, you have the pair of Hamilton's equation, which you solve. When you solve it, now I'm going to breeze through this, but when you solve that, this is what you will get. You will get 4 as your value of x, and you will get minus 1 as your value of y. And you can actually put this in there for the values of x and y to see that it's indeed correct, and it's going to give you that. You can actually do a quick check. Alright? So now to wrap up the lesson, I want you to now download. I will have an attachment with this the schedule for the lesson, and I want you to download this exercise. After you've finished watching the video, I want you to download the exercise and then solve it. It's based on the questions we've just done. Solve it and then send your answers to my inbox, and that will give me a good idea of how well you've really understood today's lesson. At this point, I'd like to stop. Okay, and if you have any questions, you can send questions to my inbox. Thank you so much for your time, and stay safe. Bye for now.